C# has a lot of operators. Some of them can be overloaded to change the behavior of how they work. Let's look at an example from .NET where this is applied. I've constructed two instances of the struct datetime. You can learn how to properly work with dates and times in .NET in one of my other courses. These aren't numbers. In fact, it's two references to instances that represents a date and time. So what would subtracting one date from the other mean? Let's say that we want to figure out how many days there are between two dates. If we subtract, this will result in a completely different type. This is a time span, which will give you the total days, minutes, seconds, and so forth that have elapsed between these two dates. This is a great example of where overloading an operator makes total sense. The datetime struct introduces a lot of operator overloads, one of them for subtraction. This takes two instances of datetime and returns a time span. Introducing an operator overload may seem simple at a first glance, but sometimes it can be rather tricky. For comparison operators, such as equals, you're required to also implement not equals. This is true for less than and greater than as well. If you ever have to introduce an operator overload, it's a great idea to consult the Microsoft Docs to ensure that the specific operator is overloaded in accordance to their recommendations. Implementing an operator overload requires you to follow this pattern. You need to declare a public static method followed by what this will return. The return type can vary. It doesn't have to be the same type as the class that you are adding it to. And the type is sometimes dictated by which operator that you are overloading. You then use the operator keyword followed by the operator. The final part of the method signature for this overload are the parameters. This is also dictated by the specific operator that you are overloading. In our example, let's say that you want to allow two orders to be combined. To make it easy, you want to overload the plus operator. That would enable you to add one order to the next and have an order returned. In most situations, a better approach would have been to introduce a method called combine that do exactly this. Introducing an operator overload could introduce unnecessary complexity in your codebase. I'd recommend that you really think more than once before introducing an operator overload. In situations where it feels natural to perform addition, subtraction, or any of the other operators, such as in the case of datetime, that would be a viable case for introducing an operator overload. If you want value-based equality, that is where you'd compare the value of the properties instead of the reference. I'd recommend that you resist the urge to overload the equality operator yourself, and instead wait until later in the course where you will learn about record types. If you really can't wait and you want to introduce value-based equality, you can generate this with the help of Visual Studio. Simply go to the class declaration, click on the tooltip, and choose to generate equals and get hash code. This lets you select the properties of the class that you want to include in this value-based equality. Here's also an option to implement I equatable of t, as well as the operators. If you check both of these checkboxes and hit OK, this will generate some code for you. First, it will add the interface implementation to the class for IEquatable. This introduces the public method equals that returns a Boolean which lets you compare the current instance with another instance. As you can see in the method body, it compares the properties with each other to validate that the values of both the instances are the same. It then adds the override for the equals method that accepts an object. This is then passed to the other equals method, with this object cast to an order type. It also overrides the method getHashCode. Doing all of this yourself manually can be tricky, so use the built-in tooling to help you generate these methods. Finally, it also introduced two operator overloads, one for equals and one for not equals. This will let you compare two separate instances of orders, and it would then compare the properties with each other. You can pause the video and try this out. Run the application with the debugger attached and see how this works. C# also provides the capability of overloading something known as a conversion operator. If you introduce a type, such as the order that we have been working with, if you want to cast this to, for example, a decimal, the compiler would tell you that this doesn't work. That makes sense, because what would converting this into a numeric representation entail? There is a way to define this, and that is done with the conversion operator. There are two types of conversions: implicit conversion and explicit conversion. An implicit conversion is, for example, when the compiler can implicitly determine the type that you want. A good example of this is a method call or a variable declaration. Performing this conversion should be safe. Hence, it shouldn't throw any exceptions, and it shouldn't lose any data. On the other hand, you can require that the type is cast explicitly. This will then also mean that you do not guarantee that it will always work, and that data can be lost. This is why there are two additional keywords, implicit and explicit, that are both used together with the operator overload that we've been looking at. The only difference between using these two keywords is what we've just talked about. One will be used for implicit conversions, and you guessed it, the other one is used where you perform an explicit conversion. Instead of the operator, you declare the type that you want to convert to, and the parameter is the type that you convert from. You could introduce a conversion that allows for the order to be cast to a decimal to get the order total. This may make sense, but it doesn't make sense to do the other way around. It wouldn't make sense to convert a decimal into an order. You do not have enough data to convert that back to the order. Although, in a lot of cases where you do overload the conversion operators, it also makes a lot of sense to do it both ways. As an interesting side effect of introducing implicit conversion is that if you pass an instance of an object into a method, such as console WriteLine, it may use the implicit conversion to get a representation instead of using toString. Many developers will go through their entire career without having to write any operator overloading at all. If you end up in a situation where you have to introduce it, maintain, or change an operator overload, you now have an idea of what that entails. And it's a really good idea to consult the documentation for each of the operators that you wish to overload. With a brief understanding of operator overloading, let's now switch gears. Next, we'll be looking at how you can extend a type with a method without having access to the class. It's time to introduce an extension method.